Here we have a sample problem that says if 10 grams of copper is placed in a solution of 20 grams of silver nitrate, what reactant will be the limiting reagent? So the wording, we have to be a little bit careful here. What it's saying is that not that the solution is 20 grams, but the solution contains 20 grams of silver nitrate. What we can also see right away is that we have an element and ionic compound reacting, and we need to build ourselves a balanced chemical equation because we always need a balanced chemical equation when we're doing stoichiometry. Element and ionic compound means we're dealing with a single replacement reaction, and in order to get the products, we're going to switch the copper and the silver because the element is a metal. That also means that we're going to produce silver as a pure element, and we're going to produce copper 2 nitrate. In order to balance out the nitrates in the copper 2 nitrate, though, we need 2 moles of silver nitrate, and because we have 2 moles of silver nitrate, we also need 2 moles of silver. So our balanced ratio is 1 to 2 to 2 to 1. Next thing we're going to do is we're going to write out our knowns and unknowns. Now for a limited reagent problem, it does not matter which one you pick as your unknown. And that's an important thing. You are actually going to pick what you're solving for in this type of question. The question is not going to tell you. So you need to take the initiative and pick which one you want to solve for. Now I've picked the silver here because the silver has the simplest molar mass. I can just read it off my periodic table as 107 and 87 hundredths of a gram per mole. You could do this with the copper 2 nitrate as well. The molar mass calculation is going to be more complicated, which is why I didn't pick it, because every extra calculation is a chance to make an extra error, and silver is literally the easiest you could get it, so why wouldn't you pick the easier one? But if you did it, you will get different numbers than me, but you'll still get the same answer in the end. So, what do we know here? Well, here we actually have 2 sets of knowns, and this is something that throws people off sometimes because they see 2 sets of knowns and like, what do? I have everything. Well, what you're going to do here is you're going to solve for a different unknown, and you're going to solve for it twice. So for copper, the information we know is that we have 10 grams. We have a molar mass of 36 and 55 hundredths of a gram per mole, and we have a ratio of 2 silvers for 1 copper. And remember, that's a molar ratio. For the silver nitrate, we know we start with 20 grams of silver nitrate. Its molar mass is 169 and 88 hundredths of a gram per mole, and its ratio is a 2 to 2 ratio. So we have 2 silvers for every 2 moles of silver nitrate that reacted. So remember that not only will the molar masses be different in these calculations, the ratios might be as well. So it's really important that you balance out your chemical equation. It's also really important that you pay attention. For the copper, you have to pair the copper and the silver. For the silver nitrate, you have to pair the silver nitrate and the silver. Don't mix them up. And then all I'm going to do is I'm going to do 2 stoichiometry problems. I'm going to solve for silver twice, starting once with the copper and starting once with the silver nitrate. It'll work the same way both times though. I will take a mass, I will cancel it with that chemical's molar mass, so that means I'm flipping the molar mass upside down. I will use the ratio to cancel out the original chemical and end up with the silver, and then I'll use the silver's molar mass of 107 and 87 hundredths of a gram per mole to figure out what mass of silver I would produce in the end. Now, technically, you don't need the molar mass of silver. You could actually end this with the number of moles of silver. I have found over the years, though, both for myself and for my students, that finishing this all the way to the grams makes it less likely that someone makes a mistake. Because it is sometimes a mistake people will make is they'll get to moles and they'll end it there, but you actually have to go all the way to moles of silver. And if you're going all the way to moles of silver already, sometimes it's just easier to go all the way to grams in the end because you have to think less about where you have to stop, and it gets you the same answer in the end. So when we do these calculations, we'll do 10 grams of copper, divided by 36 and 55 hundredths of a gram per mole times 1 mole of silver divided by 1 mole of copper times 107 and 87 hundredths of a gram per mole to tell us that 10 grams of copper will net us 33 and 9/10 of a gram of silver. But then when we do the calculations for 20 grams of silver nitrate, we'll divide by 169 and 88 hundredths of a gram per mole. The ratio is a 2-to-2 ratio, so it actually cancels each other out. And then we multiply by the silver's molar mass. We only get 12 and 7/10 of a gram per mole. So even though there's twice as much silver, it's actually the limiting reagent by a significant margin. You are going to get less than half the silver produced out of that silver nitrate than you will out of the copper. So that means that our silver nitrate has to be our limiting reagent for this reaction because we're producing less silver from the silver nitrate than we could produce from the copper.